Good morning, everyone. Trust you're doing well. I'm M. Swati, working as an assistant professor in the Department of CSC. Topic I will be delivering is on subprograms and principles of programming language. Subprogram. By definition, a subprogram is a self-contained module which performs specific task. It has its own declaration and code. Coming to a specific task, which means whatever the task the user is intended to perform. For example, be it addition of two numbers, be it swap of two numbers, matrix multiplication, or any kind of application the user want to create. So it is very independent module which is having its own declarations and also the executing the processing statements. So use of subprogram provide code reusability, which in turn saves memory and coding time. Code reuse aims to save time and resources and reduce redundancy and leads to cost-effective programming. Coming to general characteristics of a subprogram, every subprogram will have a single entry point. The calling program unit is suspended during the execution of the called subprogram, which implies that there is only one subprogram in execution at any given time, which means since we already discussed mentioned in the earlier slide that each subprogram is an independent module, the local declarations are confined to the module itself. So as and when control shifts from the calling program to the called program, the control is in the called subprogram, where it takes the input from the calling program unit as a parameter and the computation is done in the called subprogram itself. When the computation is performed and it is ready to deliver the output is again sent back to the calling program unit where then it resumes back. So control always returns to the caller when the subprogram execution terminates. As and when the subprogram execution is finished, the control is shifted back to the calling program unit. Elements of subprogram. The important elements of a subprogram or a function are subprogram definition, subprogram call, subprogram header. Subprogram definition, it describes actions of a subprogram abstraction. So what kind of task it is going to perform? What are the local declaration? What are the processing steps it has? And what are the statements that it's going to execute and give as a resultant? Next comes subprogram call. It is an explicit request to the subprogram for execution. Through this subprogram call, you can invoke any definition depending upon the same function name. So the corresponding called subprogram will get active and it will try to execute whatever the steps that it has performed. Subprogram header. It has a special word, maybe a name of a subprogram, and it also has an optional part. So these are the examples of how an subprogram header look like. So the first example is def adder parameters. So this is a header of Python subprogram with function name or a subprogram name called adder. So a Ruby subprogram will also have the same definition or the subprogram header which starts with def. As a most familiar example which we see in the C programming language is the C programming header. In a given example, we have a return type called void or a data type and the function name as adder followed by a list of parameters and the body of the subprogram. So here we have used a reserved word called void, which indicates that the subprogram doesn't have any value to return to the calling unit. If suppose you have an integer there, so the subprogram after computation of these statements, it will return an integer value to the calling unit. Similarly, if float value is mentioned, it will try to return float value to the calling unit. By default, any subprogram can return an integer as the return type to the calling program unit. So these are the different headers mentioned in C program which we have discussed now, which has no special word. In Fortran, the subprogram header will look like with subroutine, function name or the subprogram name followed by parameters. In other programming language, it has a special word called procedure followed by adder and then followed by parameters. So coming to the parameter profile. A parameter profile is nothing but what kind of parameters we can declare before a function definition has started its execution, how many parameters, what is the order of the parameters, and how many parameters we can actually pass as an arguments to the function definition. So in parameter profile, the important points to be discussed are the parameters will have a number, order, and types. So the number of parameters, the order is very important because the control will try to identify the order in which the data types are specified, whether the int float char or int float or float int whatever. So these kind of data types should be in the same order when we are trying to discuss or the control we are passing parameters to the function definition. And the protocol contains the parameter profile, and if it is a function, its return type is also considered. Subprograms can have declarations as well as definitions. Since whatever declarations like local variables, whatever we have to mention, we can also explicitly mention them in the function body of a subprogram. So these are the common practices we see in C, Ada programming language, and Pascal. But Java doesn't allow declarations of its methods. There are two ways that a subprogram can gain access to the data that it has to process. One is through direct access to non-local variables, the other is to parameter passing. In direct access to non-local variables, here the declaration is made elsewhere but visible in the subprogram. If data access is through non-local variables, the only way the computation can proceed on different data is to assign new values to those non-local variables between calls to the subprogram. In parameter passing, it can perform its computation on whatever data it receives through its parameters, presuming the types of the parameters are as expected by the subprogram. Coming to types of parameters. In formal parameter, it is a dummy variable listed in a subprogram header and is used in the subprogram. It is usually bound to the storage when subprogram is called. Actual parameter. It represents a value or address used in the subprogram call statement. Positional parameters. It is bounded by position. The first actual parameter is bound to the first formal parameter and so forth. Keyword parameters. It is used for a long parameter list. Name of formal parameter to which an actual parameter is to be bound is specified. This is an example of a keyword parameter where we have uh, mentioned the formal parameter to which the actual parameter is to be bounded. This is an example of how a swap function is mentioned. We have taken an example to swap two numbers using pointers. Here, in the swap function, the main swap logic is written. This swap function or function definition of swap will expect the address of the variables as parameters. You take an explicit declaration of a local variable and using that local variable you try to swap the values. So coming to the most important elements of a function here, void swap int asterisk and int asterisk is the declaration part of the function swap. As we mentioned, the keyword void specifies that this function definition has nothing to return to the calling program. In the swap logic, in the function call of swap, you are passing address of the parameters as arguments, and these addresses are passed as parameters to the function definition, and the local variables takes the values and tries to swap and then print back the result. So this is how function definition, function declaration and function call will help in individual programming of the individual blocks of a subprogram. Thank you.